Hello, good morning, and this is the first discussion for our course, Vibration Engineering. I will introduce you to the general knowledge about mechanical vibrations. So, ito na yun. Yan. So, this is mechanical vibrations. Ano nga ba yung mga knowledge natin about mechanical vibration? What is vibration? What is vibration engineering? Ano ba yung mga good and bad vibrations? Ano ba yung mga bagay na kailangan natin consider kapag merong vibration? And bilang engineer, someday, you will become a professional. Ano ba yung mga bagay na dapat mo i-consider para, ano, makombat mo or ma-take away mo yung bad vibration sa isang moving member? Since someday, you will become designers, professional engineers, malalaman mo kung ano yung mga effects ng vibration dun sa iyong moving parts, moving machines, machine members, if they are disrupting the performance of your engine, if they can be quite destructive pagdating ng iyong structures. Yan ang vibration engineering. Hindi lang tayo panay machine design, but this is very important kasi kailangan natin yan. Number one, to ensure safety. Number two, to make the performance of your machines into optimal up to its maximum conditions. So let us see. As we can say, a body is said to vibrate if it has periodic motion. Ano ibig sabihin nun? Ang ibig sabihin, when something, okay, like a machine that moves in a periodic motion. Ano ba ibig sabihin ng periodic motion natin, mga kaibigan? Periodic motion, ibig sabihin your motion is repeating. A motion that repeats. Okay? So, yan yung ating periodic motion. Pag nag-create ka ng periodic motion, vibration na agad yun. So, yun pa lang yun vibration pa lang. Paano kung mechanical vibration? It is the study of oscillatory motions. Ang vibration is synonymous to oscillations. Yan. Pag sinabing oscillatory body, it is a vibrating body. Which moves in a periodic motion. Now dito sabi, vibrations are oscillations of a system about an equilibrium position. Tama nga naman. You have to determine what is your equilibrium position. Ang equilibrium position is where all the motion starts and at a certain distance that a body will tend to move periodically. So, ito yan. Meron tayong X and Y graph dito kung saan we can plot yung ating position within the time interval. Since time is an independent variable, we can determine the position of a moving or oscillating body from its starting position. Now, let us see this one. Okay? Meron tayong model. And that model is a spring model kung saan meron tayong masses that is applied. Ngayon, at a certain distance, your spring will be deflected. Okay? Ito yung zero position niya. Yung spring mo will be at zero position. Ngayon, when an impact is created, your spring will tend to move at x distances for its distortion. Or, anong tawag doon? Deflection. Ngayon, yung deflection na yon can be pwedeng bumaba dito. Okay? So, from here, bababa siya, pero at a certain way, your body will tend to go to its original position. And that is vibration. Okay? Yun ang definition ng vibration. Now, vibration. Sabi dito, vibration can be found anywhere and everywhere. Bakit? Ngayon, merong malikot na utak, nag-iisip, vibration. Alam ko na yan, sir. Expert ako dyan sa vibration na yan. Kasi, sir, sakay ko LRT. Di ba, sir, kapag ang LRT napakatuloy ng takbo, nagbabibrate yan? Siyempre. Nagbabibrate yan. Kasi ang LRT, nasa isang non-moving rail. Ang gumagalaw lang, siya mismo. So, yung rail na yon, kapag naka-experience ng load, it tends to vibrate. Kaya nga, makita nyo, yung mga relays, meron silang mga yung gravel, yung ang lalaking graba, di ba, na bato. And those gravel helps to to absorb the vibration of the ground where your rails are fixed. Ayun, pag nagba-vibrate yun, ina-absorb ng mga bato yung vibration. Yun yung purpose nun. At ano pa, pagdating ng yun sa mga parking lot. Parking lot, bakit nga pa may graba? Hindi dahil sa vibration. Yung graba na yun, it absorbs the motion. Ito safety feature din siguro pagdating sa inyong mga kotse para hindi siya mag-freely move. Yung graba na yun creates friction between the tires and dun sa ground. And then nag-absorb yan nung motion nung iyong tires. And ang vibration naman kasi, papasok dyan yung dampings kung saan i-absorb niya yung impact. Yun. Dampers ang tawag. Ito pa. Yung vibration na yan, nakakahilo. Merong vibration na nakakahilo. Yung in a stormy sea, in a troubled sea, kung saan napakalalaki ng alon, sumakay ka ng bangka, you feel seasickness. And that seasickness is because of the unwanted vibrations. Okay? Meron mga taong seasick. Nahihilo sila pag sakay lang ng bangka. Kasi, yung alog ng bangka is somehow an oscillating motion. Paulit-ulit. So, kapag nagkaganon, naalog yung itong utak mo, pag naalog yan, medyo mahihilo ka. Kaya you feel seasick. Ano pa? An engine, okay, that you use in a certain machine that produces vibration. And those vibrations can be harmful, number 1, to your machine. Number 2, to the person that is operating the machine. Pero, mas great ang effect niya dun sa machine. Kasi, yung machine mo has a wear and tear. Nababawasan yung kanyang use life kapag meron ka unwanted vibration. So, how will we combat vibration dun sa ating moving machines? Ang gagawin mo dyan, you use sa machine foundations mo. When you go to your power plant design, you will consider yung weight ng machine, yung speed ng machine in terms of RPM, the power that is produced in your machine or the brake horsepower that your machine produces para para makalculate mo yung foundation. And yung foundation na yon, hindi lang basta concrete ang lalagay mo dyan. When I had worked in a power plant, yung kanilang massive diesel engines na nag-range ng 20 megawatts per engine for production, meron niyang footings. Yung footings nila that is made in concrete, pero hindi lang mismo concrete siya. Yung concrete na yon ay meron niyang nakalagay na industrial grade rubber dampers. Sir, para saan? Tignan nyo yung bagay na stiff like this one, this is your screw. And this is the one na lalagyan ng screw hole mo doon sa footing ng iyong machine. When that machine vibrates, ang nangyayari, yung hole na yon, when you go back to your strength of materials, ang nangyayari doon? Nagbe-bearing, di ba? Nagiging slot yung hole. Kasi nga, nagba-vibrate yung machine mo. And in order to absorb that vibration, you employ dampers or shock absorbers. Yung shock absorbers na yon, they prevent the breakage and they prevent the buckling. Number 2, the bearing of your footings, yung slot sa footings. Okay? Yun yung ganun yung mga paraan para i-combat natin yung effects of unwanted vibrations. Another one, your cars. Sabi nila, bakit yung ibang cars, V ang engine, V-type ang engine. Yung kanyang engine is V-type, yung iba inline. Yan, inline. Ano ba nagagawa nun, sir? Tapos meron tayong boxer type. Yung boxer type. Yan, yun yung engine natin. Meron kang V, meron kang inline, meron kang boxer type. Bakit nga ba yan ganyan? Yung mga configurations ng machines na yan. A V-type engine, base din sa experience ko. Kasi nung bata ako, meron kaming maliit lang na talyer. So I kept on watching yung ginagawa nung yung magulang ko yung Land Cruiser, yung mga Untitled Jeep. Karamihan dyan inline. Pero there came a time na nakakita ako ng V-type. That is a Mustang, an old Mustang. Hindi ko alam kung buhay pa rin yun. But, nakita ko yung kanyang engine is nakaganon. Parang And that engine produces a lot of power. Pag ganon. And V-type engines kasi, medyo malakas ang vibrations niyan. Pag ganyang configuration. And V-type engines kasi, takes much of the hood space ng iyong sasakyan. But, tandaan nyo, ang V-type engine configuration, sa V-type na yan, it can produce a lot of power. Nakaka-affect din yung kanyang configuration, yung position sa pag-produce ng power. Yung incline yan, merong certain incline yan. Hindi ko lang maalaman kung ilang degrees. At hindi ko matandaan kung ilan. Pero that produces a lot of power. Now, for inline engines, bakit ginagawa nila yan? Makita niyo yan sa kanyo, kapag in-start niyo yan sa kanyo pag inline engines, yung mga jeep, depende yan eh. Kapag inline, pwedeng nakaganon, parallel, or perpendicular. Sa Toyota Vios, ang engine mo is tawag dito, that is perpendicular sa wheels. Hindi siya parallel. So, kapag inline engines, nakakatipid ka ng hood space. Yun lang yun. And then, the vibration is, ganun lang, nababalance out lang niya. Taas baba lang. So, hindi nagbabibrate yung kotse mo na side to side. Itong V-type, side to side yan. Yung boxer engine naman, medyo space consuming yan. Dahil, bakit siya tinawag na boxer? Para daw siyang sumusuntok. And this boxer type engines, makikita niyo yan karaniwan. Porsche engines, a Volkswagen Beetle. Ano pa? Meron pang maganda example dyan. Alam niyo yung 86 ng Toyota? Pati yung BRZ. BRZ ni Scion. Or the Subaru. Yan ang mga engines niyan. And vibrations. When you create music, you are producing, or when you produce vibrations, you are creating music. Hindi ko lang alam kung maganda, or good, or bad. I don't know. So, vibrations are harmful for engineering systems. Sinabi ko na nga. Kasi nga, unwanted vibrations create wear and tear and disruption to your engine performance. O yan. Sometimes, it can be useful. For example, vibratory compactors, yung ginagamit ng ng mga yung nag-iispalto ng lupa. Makita niyo yan, gaganon sila sa lupa. Ino-compact nila yung concrete. Masakit yun dito. Okay, so yung vibrations nun, effect niya dun sa operators, medyo disrupting. Number 2, yung excessive vibration causes discomfort to human. Yun na nga yung effect nun eh. Tapos yung unwanted vibrations, kumare, pangit na music, masakit sa tenga. Kasi, yung mga olfactory nerves nyo dito, yung mga eardrums nyo, they react to vibrations, and then vibrations and sound waves. Pag unwanted yung sound waves coming from unwanted vibrations, masakit sa tenga, masakit sa ulo. Now, the study of vibration is important too. Number 1, sa ating mechanical. Number 2, sa aeronautical. And number 3, sa civil engineers. Sir, ano ba yung pinaka-disruptive na vibration? Meron, yung ginawa si Mother Earth. Ano yun? Yung earthquake. Harmful yun sa civil engineers kasi, number 1, lahat ng structural integrity na ginawa ng civil engineer sa kanilang structure sa buildings, pwedeng masira yun kapag hindi maganda yung pagka-adapted mo dun sa system mo. Kaya, pagdating dun sa mga Dubai, we can build as high as we want to. Sabi nga nung prince ng Dubai. Kasi, we have good engineers. Okay? Yung Burj Khalifa, Burj Al Arab, yung mga yon, gumamit sila ng damping system para nag-simulate din sila ng mga earthquakes para ma-test nila yung building nila will move. So, they employ dampers to combat the effects of earthquake. If ever na magkaroon ng earthquake. Kasi nga, ang tataas nun eh. That is beyond the sky. And it is necessary for a design engineer like us to have a sound knowledge of vibrations. Now, yung mga yon, kailangan natin consider kasi nga, pag naging professionals tayo, hindi lang naman tayo gagawa ng building, hindi lang naman tayo gagawa ng something that is for projects, but we are doing this. Nag-engineering tayo to make life better for every one of us. Kaya, we have to consider vibrations. Kailangan, nandito yan eh. Yung knowledge of vibrations. Kasi, you have to consider this para yung lahat ng gawa mo, wala kang disruption. Okay? Now, this will cover yung entire course natin, the fundamentals of vibration. Okay? Hindi lang yan. Yung undamped and damped single degree of freedom systems, multi-degree freedom systems, and continuous systems. And later on our discussion, ipapakita ko sa inyo kung paano siya, ino-compute, ina-calculate. At paano ka gagawa ng free body diagram or free vibration diagram. Kung saan ika-translate mo yun, saan? Sa calculation. Okay? Next slide. Yan, mechanical vibration. So, meron tayong mechanical vibration na magagamit natin sa ating workout. Ito, yan Ano to? Massager yan. Massager. Mga nangingisip dyan kung ano naisip nyo. Wad yan. Number 1 yan. Si Asurin. Saka si Wang. Si Susi. Susi ano naisip mo dyan? Ito, yan, jackhammer. Your heart vibrates. It oscillates. Kasi meron siyang periodic motion. Hindi pwedeng huminto ang puso. Pag huminto ang puso, wala ka ng mahal. Joke lang. Hindi ganun yun. Hindi ganun yun. Kapag huminto ang puso, tepo ka na. Deads ka na. Your washing machine, nagbabibrate yan. Ito. Your vocal cords vibrates and it produces sound. Sabi nila, when you turn up the music too high, And you can feel the vibration. Medyo masakit na sa ulo. Kaya, you make this grip. Okay? Now, ayan, meron tayong mga useful and harmful vibration. Ito, useful vibration. Bakit sinabing useful vibration? Those vibrations, when created, produces something na beneficial to us. Yan, yun yung mga useful vibration. Yung compressor, yan. Meron tayong testing nito. Ultrasonic cleaning, yung vibration yan ay na ano, saan ba ginagamit ng ultrasonic cleaning? That is used to to take away the rust into metal parts. No, yung harmful vibration, masakit sa ulo yun kapag nag-create na sila ng noise. Meron kang distraction, nasisira yung makina mo. Ayan, yung wear dito sa bearing dahil nagba-vibrate din naman ng shafting mo, hindi lang yan panay torque and power. Kailangan din may vibration and then fatigue. Yung fatigue na yun, yan ang that causes the machine to fail. A machine member to fail. Fatigue. O ito yung three parameters that you have to consider when tackling about vibration systems. Number 1, you have to consider the mass of the body when talking about vibration. Bakit? Because the motion of a rigid body stores kinetic energy. And that kinetic energy depends also on the mass of the body. Hindi lang yung velocity. Because if a body has no mass or a smaller mass, will also result into a small kinetic energy. And you have to consider yung mass ng isang bagay and the kinetic energy of a moving body in order for you to counteract the effects of vibration. Kasi nga, yung dampers mo will absorb a certain vibration at a certain amount. And considering that, yung motion, yung energy na yon, kasi that will be absorbed by a damping body. And that damping body, like a spring, a shock absorber, will require a stiffness. And going back to your strength of materials, stiffness. Ano ba yan, sir? Yung pagiging matigas? No. That is not the real definition and the required definition of stiffness. Stiffness is the deflection of a flexible component. It stores potential energy. Kasi yung potential energy na yan, at rest. It is an energy at rest. Okay? When a sudden impact from a moving body having a kinetic energy, ilalaglag mo sa isang spring that has a potential energy. That potential energy will have equilibrium with your kinetic energy. And kinetic energy will somehow be absorbed by your flexible component, which has a certain stiffness. And that stiffness came from what? Hooke's law. That is K. Hindi to wall factor. Hindi yan wall factor. That is stiffness. Ano ba measure na stiffness mo? That is pound per inch or kilogram per cm kapag springs. Okay? And kapag nagkaroon ka na ng dalawang yan of interaction between mass and your stiff body, magkakaroon ka na ng damping effect. And that damping effect is the phenomenon where you can absorb vibration energy. Ayan. Ito na yun. Okay? Naintindihan natin? So, when you have mass and a stiff body, when they interact with one another, you can have the damping effect. Yun lang yun. Okay? Next. Ayan. So, this is now the mass spring model. Gagawa tayo nito. This is the representation of a cylinder and piston machine. The cylinder and piston machine a machine that is moving from top dead center, ito yun, TDC, to bottom dead center, dito sa baba. Now, meron kang flexible mounts. Ito yung nag-absorb. These are dampers or shock absorbers. And it moves in periodic movements. Ito, T. Now, you will create a mass spring damper model. Kung saan your spring and the dampers will counteract the mass M that is moving. Yan. Gagawa tayo ng mga model yan later on in our discussion. Okay? Now, we have several types of motion. So, meron tayong simple harmonic, meron tayong free vibrations, meron tayong forced vibrations, natural vibrations, yan. And then forced vibrations, meron din tayong mga damping. Yan lang naman yung mga simple definitions. Now, for simple harmonic motion, as defined, it is an oscillatory motion where the net force on the system is a restoring force. In physics, repetitive movement back and forth through an equilibrium, so up and down, or a central position, so that the maximum displacement on one side of this position is equal to the maximum displacement on the other side. Ibig sabihin, pag simple harmonic motion, the motion at rest, okay, the maximum movement of your moving body to a certain distance will come to a halt on its original position. Ibig sabihin, walang magbabago. Okay? Kung paano kayo nagsimula, ganun din matatapos. Sabi nga ng Ben and Ben, pag nilahad ang damdamin, sana hindi magbagong pagtingin. Yun, parang simple harmonic motion. From the start to the end, it's the same. Never changed. Pero, some things don't come easy. Talagang ganon. Everything changes for a reason. And going back, it is considered as the projection on a diameter of a movement of a uniform speed around a circumference of a circle. Pwedeng ganon. Pero, saan parang ang hirap? Ang hirap intindihin. Ganito na lang yan. Let us put this one into pictures. Let us define a picture. Perhaps you can see a spring and a ball that has a mass. And this spring, sinabi ko nga kanina, it has a certain deflection lang. Hindi mo siya pwede i-compress. Okay? Between its solid length. Okay? Ay, compressed length niya. Okay? Compressed length. Hindi mo na siya pwede i-compress beyond that. And dito, kapag hinila mo yung spring na yan, okay, hinila mo pababa yung spring na yan, theoretically, pag binatak mo siya and enough energy is stored dun sa spring mo, yung spring mo ngayon, babatakin niya pa ulit-ulit yung bola. Hanggang sa huminto siya. But the motion of that body, every time, within a given time, okay, will repeat itself theoretically into equal displacements. Yun yung ating simple harmonic motion. So, magdo-drawing ako dito. Ito yan, X and Y. Ngayon, at first, maximum displacement mo. Pag bumalik yan, equal lang hanggang sa papaliit, hanggang to a 0 point. Yan ang simple harmonic motion. Ibig sabihin, the displacement on one side will be equal to the displacement on one side until rest. Never changes within a given time. Okay? Kaya, sir, sabi nila, there is such a thing like a, anong tawag doon? Perpetual machine. But no. A perpetual machine is somehow, an impossible thing. Kasi, it defies the laws of physics and thermodynamics. At That's why, sabi nila, scientists and then inventors, wala talagang simple wala talagang perpetual motion machines. Kasi nga, sir, pag ang perpetual motion machine mo, okay, nagkaroon ka, you're not living in a world that follows the laws of physics. Okay? A machine should always follow the laws of physics and thermodynamics. Yun lang yun. And ito yan. Ito, GIF to. So, pag nag-move yan, meron siyang certain acceleration. Yung acceleration niya with the given time will be equal then. Yung velocity, it will not change. And then, syempre, yung displacement niya, ganun pa rin. Ganyan, simple harmonic motion. The velocity, the displacement, and then the acceleration remains the same. Ito pa. Yung simple harmonic motion defined as periodic motion of a point along a straight line such that its acceleration is always towards a fixed point in that line and is proportional to its distance from that point. Ito yung representation. Now, for vibrations, meron tayong dalawang uri dyan. Free and forced. Free, from the word itself, okay, niyaan mo lang siya. Free, malaya. Vibrations that occur in the absence of friction. Wala kang external effect na nangyayari. So, yun lang, meron ka lang moving part na walang friction, walang resistance, it just moves. Okay? Kapag wala kang friction, wala kang external force, yan ang mangyayari, yung vibration mo will not tend to end. Hindi siya matatapos. So, this one is somehow possible, feasible, hindi natin alam. Kasi, pag wala kang friction, okay, yun lang, matagal yung iyong motion. Like a simple pendulum, hanggang sa, huminto na lang siya. Hindi natin alam kung kailan. Now, force vibrations. When repeated force continuously acts on a system, the vibrations are said to be force vibrations. Kapag meron ka ng system, yun, yung mass damper, and spring diagram. Ito yung representation. Yung pendulum inaklak. Kailangan mong kailangan mo muna siyang yung grandfather clock, yung merong pendulum, kailangan mo muna itulak yung para gumana. And then at some point, yung stored energy doon nawawala. Okay? Kaya kailangan from time to time, ginagalaw mo yung pendulum. Now, for natural vibrations, as the name implies, is the frequency that at which the system resonates. Ano ba yung resonates? Okay? In the example of mass and beam, the natural frequency is determined by two factors. Number one, yun, sinasabi ko kanina. The amount of mass and the stiffness of the beam. Now, yung vibrations mo, nakadepende pa rin yan dun sa mass and stiffness, yung tigas na isang bagay, which acts on a spring. A lower mass or a stiffer beam increase the natural frequency, yung paggalaw niya. So, like a spring, hanap tayo dito. This one, ang stiffness niya mababa, and then when you apply a certain mass, ayan, at a certain point, yung vibration niya is ganun lang kahaba. Now, a stiffer body. Yan natin, a stiffer body. Meron ako ditong, ito. Ayan. Tignan nyo, yung vibration niya, mahaba kasi mas stiffer ito. Ito, medyo mas malambot. So, yung vibration niya, maikli lang, unlike nung the other one. Okay, ganun lang yun, natural vibration. Force vibrations. May tatlong bagay para makapagkaroon ka ng force vibrations. Number one, step input forcing. Number two, harmonic forcing. And then periodic forcing. And we will tackle that about on the next topics natin. So, yun lang yung force vibrations. Meron ka ng system. Yan. Force vibrations, the tendency of one object to force another adjoining or interconnected object into vibrational motion. So, meron ka ng system. Meron ka ng mass, meron kang dampers, meron ka spring. It is when an alternating force or motion is applied to mechanical system. Example, when a washing machine shakes due to an imbalance. So, makikita niyo yung washing machine nyo, meron niyang mga ano sa loob. May mga parang retaining springs. Hindi lang yan basta-basta, nasa loob lang yung canister. So, pag umikot yon yung dampers doon, yun yung hihila, imbis na yung casing. Nalilesen niya yung vibration. Yan. It is when an alternating force of motion is applied to mechanical system. Ito na yun. Now, damping, yan na yun. Yung damping, you employ such phenomena para ma-restrain mo yung vibration motion. And by definition, yan nga, restrain of a vibratory motion such as mechanical oscillations. Yung noise, meron kang mga pads. Ang tawag doon is, acoustic pads. Yung dinidikit sa mga recording studio. Minsan nga, dinidikit nila yung mga tray ng itlog. Para para ma-dissipate mo yung production of unwanted energy. Unless, a child keeps pumping a swing, sakit sa tenga yun. Its motion dies down because of damping. Pag nagkaroon ka, shock absorber. Yan. In automobiles and carpet pads, pagdating ng mga floors mo. Para para yung wood floors mo, hindi masira agad katatapa. Meron ba tayo example dito? Yan, no? Ayan. This is a damper. Ayan. Meron siyang damping effect. Para para syempre, hindi naman maingay yung kama mo pag natutulog ka. Syempre, paikot-ikot ka, di ba? O yan, yung mga siraulo dyan na nakakaisip ng kung ano-ano, yan, ha? Bahala na kayo mag-isip, ha? Kaya nilalagyan ng unan yan kasi masisira to o yun, masisira yung bed rest mo. Mahal-mahal ng kama ngayon. O yung iba, naglagay pa ng Showa. Naglagay ng Showa shock absorbers do sa kama. Para kasi yung kama mo, medyo pag bumibigat ka na, paikot-ikot ka sa kama pag natutulog, di ba? Hindi yan medyo gagalaw. Para safe na safe ka. Kaya meron tayong mga dampers. Tawag dito shock absorber. Yan. Showa brand. Ito rin, para hindi masira yung bagay niya. Ha? Kaya tayo naglalagay ng dampers. Now, resonance. An object will vibrate strongly when it is subjected to vibrations or regular impulses at a frequency equal to or very close to its natural frequency. Now, in physics, relatively, large selective response of an object or a system that vibrates in step or phase with an externally applied oscillatory force. Ang hirap intindihin, sir. Kahit ako, nahihirapan. Ganito na lang. A vibrating metal rod forces air column inside into vibration at the same frequency. Thus, resonance occurs. Ngayon, ginanon mo. Ayan. Resonance na yan. Ibig sabihin, yung oscillating body mo creates something na nagte-take effect sa kanya. Yung air column na nandirito, naapektuhan nung oscillating body. And that oscillating body, kung ano yung naapektuhan niya, creates a resonance kung saan yung vibration mo, inuulit nun to give it back to you. Okay? This is resonance. Ayan, yung sound that it makes, that is resonance. Okay? The effect of vibration on a certain body, that is resonance. Okay? The same frequency. Ito, may frequency yan. Ganyan kabilis ko siya, pinapagalaw. So, pag nag-take effect siya sa isang body, inuulit lang nun. Yun ang resonance. Okay? Same frequency close to that body. Now, pendulum mechanics. A body suspended from a fixed point so that it can swing back and forth under the influence of gravity. Okay? Self-explanatory na. So, kapag nandito ang iyong pendulum that stores the maximum potential energy, pag bumaba siya to its lowest point, that it has its, the maximum kinetic but zero potential. Pag nasa taas, zero kinetic, maximum potential. Nasa baba, maximum kinetic, zero potential, akit ulit yan. Hanggang sa mag-lessen na mag-lessen yung kanyang energy store. Hanggang sa huminto na siya. Okay? And that is vibration for you. And I hope may natutunan kayong bago ngayong araw. And on the next meeting, I hope you can explain this things na pinaliwanag ko sa inyo in your okay? And that will be all for today. Have a nice day. Bye-bye.